Let us explore the fascinating world of time complexity classes. In this video, we will understand computational complexity through fundamental classes. We will cover the polynomial time, denoted as P. These are the problems solvable in polynomial time. Next, we will move to nondeterministic polynomial, denoted as NP. These are problems verifiable in polynomial time. Lastly, we will explore some other important classes like space, EXPTIME, and beyond. In this slide, we are diving into the definition of the class P. The class P contains all decision problems that can be solved by a deterministic Turing machine in polynomial time. This means the time it takes to solve the problem grows at most polynomially with the size of the input. The formula displayed here, P equals the union of all k greater than or equal to 0 of time of n to the power of k, represents that P is the union of all polynomial time complexity classes. Now let's see some examples of problems that fall into the P class. First, sorting. Arranging elements in order using comparison-based algorithms like merge sort or quicksort can be done in n log n, time complexity, which is polynomial. Second, graph connectivity. Determining if two vertices are connected in a graph using algorithms like breadth-first search or depth-first search can be done in OV plus E time complexity, where V is the number of vertices and E is the number of edges, which is also polynomial. Now, let us delve into the definition of the class NP. The class NP contains all decision problems for which a solution can be verified in polynomial time. This means if someone gives you a potential solution, you can check whether it is correct relatively quickly. The formula displayed here, NP equals time of n to the power of k, represents nondeterministic polynomial time complexity. Let's consider some examples of problems that fall into the NP class. First, SAT problem. Boolean satisfiability, which involves finding variable assignments to satisfy a given formula, is NP complete. This means any problem in NP can be reduced to SAT in polynomial time. Second, traveling salesman. Finding the shortest route that visits all cities exactly once is also NP complete. Now, let us talk about the relationship between P and NP. We know that P is a subset of NP, meaning that every problem solvable in polynomial time is also verifiable in polynomial time. However, whether P equals NP remains one of the most important unsolved problems in computer science. There is a formula displayed here. P is a subset of NP. This means that every problem solvable in polynomial time is also verifiable in polynomial time. Beyond P and NP, there are other complexity classes worth mentioning. First, space. These are problems solvable using polynomial space. It has a complexity bound of space of n to the power of k. Second, EXPTIME. These are problems solvable in exponential time. It has a complexity bound of time of 2 to the power of n to the power of k. Finally, let's look at the hierarchy of complexity classes. The known inclusions between major complexity classes are as follows: P is a subset of NP, NP is a subset of space, and space is a subset of EXPTIME. Most equality questions, such as whether P equals NP or NP equals space, remain open problems in computer science. Understanding these relationships helps to contextualize the difficulty of different computational problems. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.